So this is 38,400 minus 2,230 minus 6,785, which is going to give us our z, which is 29,385 over 14,400, which simplifies to 5,877 over 2,880. Okay, so this is our new approximation for z. So let's go on and do the iteration to step 4. So iteration to step 4. Iteration to step 4. Okay, so let's write our table here once again. So iterations and values. So x, we now know that x is equal to -7 over 80. So x is equal to -7 over 80. Y is actually equal to 1115 over 1200. Is equal to 1115 over 1200. Z is equal to, and we just found it, is equal to 5,877 over 2,880. So z is actually equal to 5,877 over 2,880, and w that we still have to find is equal to well, this the old one, so 1,357 over 480. So 1,357 over 480, and this the last one we are going to find. So w is equal to, let's get the equation. The equation was 7 over 2, which is a scalar, it's not dependent by anything, minus 1 over 4 x, so it's dependent by x, minus 1 over 4 z, so it's dependent by z. Okay, so w is actually equal to 7 over 2, which is our scalar, minus 1 over 4 times negative 7 over 80, which is our best approximation for a best estimation for x, minus 1 over 4 times, well, 5,877 over 2,880, which is our best estimation so far for z. We still have to find w, so w is actually equal to 7 over 2 plus negative, so 7 over, well, 320 minus 5,877 over this guy here will be times 4, so 2,880 times 4 is actually 11,520. Okay, so w is actually equal to well, let me see, 11,520. I can actually divide it by 220 because it's 36, and of course is I can divide it by 2, so I'm gonna get 1,520. Okay, so I'm basically gonna get 11,520. So divided by 2 is 5,760 times 7 is actually, well, 40,320 plus I can divide it by 320 because 11,520 divided by 320 gives me 36. Times 7 is 252 minus 5,877, which is gonna give me our new value for a new estimation for W, so 11,520. And we have, well, we have 40,320 plus 252 minus 5,877, which is 34,695. If I got it right. So yeah, after those iterations, our full iterations, our best estimation right now is x equal to -7 over 80, y equal to 1,115 over 1,200, z equal to 5,877 over 2,880, and w is equal to 1,357 over 480. And I'm sorry, we just found it. So it's equal to 34,695 over 11,520. Yeah, it's kind of tedious to work with those kind of numbers because they're very, very large number, and I am pretty sure it's very common to make a boo-boo out of multiplying and adding and subtracting together those very high numbers. So yeah, in this case, perhaps would be better to round them up, or do this if you have a calculator, if you want to use a calculator, because doing it yourself, there's a very high chance that you might screw up. So anyway, this was the fourth example about the Gauss-Seidel method, and I basically wanted to show you that it doesn't really matter where you start from, which points you choose as your starting point, as your guess. You're basically going to get an estimation according to the iteration that is going to get better and better and better as soon as you go on. As you go on with the iteration, and it's going to converge as soon as you get a relatively high amount of iterations. So this is basically how it works.